NAT and PAT completed. So remaining we'll see tomorrow. It's already 5:38. My eyes also paining. Since morning I am sitting in front of the system. So what we discuss about a private IP addresses and public IP addresses, right? So to communicate within a private, so just you need a private IP. No need to buy, no need to register, no need to take a license to use private IP addresses in your private network. You are in your home, means you are in your own private network. To communicate between your laptop to your mobile phone, it's a private communication only. Same in our office, we are all communicating each other in our own private network. But you want to access an internet, you need a public network. Okay. Without public IP address, you can't communicate outside of your network. So you are connected to internet, right? So you are connecting to internet. So through ISP or anything. So but you are connecting to your internet. Through ISP you are connecting, but internet is public. So you are communicating from this device to this device, this device to this device. So you don't require any private IP address. Just you can able to communicate directly A to B, B to C, C to D. They are able to communicate in your within your intranet, a local or a private network. It is your intranet. It required a private IP. But you want to access google.com, facebook.com, youtube.com. You want to access it, you need a public IP. So here it is. I close that one now. Okay. So what is my IP address? IP config. Just IP config. So look at what IP address I'm having. It's a private IP or public IP. Anyone? Yes. See the private IP address ranges and check this. Yes, I am using private IP or public IP address. Where is be written private IP? Here it is. Okay. 170.16 means it's a private IP. Right? So what is the IP address? 170.16. So what I'm using is a private IP address. But how can I able to access internet? I am using youtube.com, right? I'm using youtube.com, Google Docs I'm accessing, WhatsApp I'm accessing. How can I access the publicly available things? Those are not in my system, right? In our system, we have our own servers. That is, we can connect privately, but which is outside of our network. So for that communication, we need a public IP, but my IP address is private IP. In my system, it's showing private IP address. How we are accessing public network. Okay. So for your communication, so what you will do, you send your request to your router. Means if anybody want to communicate outside of your network, you have to go through the router only. And router to modem. It's a router can be a Wi-Fi router, or if it is a Wi-Fi router, it is also with a modem, right? It's a modem, router, modem, okay, ISP, and internet. So simple it is. So it's what I'm trying to say is for communication from one network to another network, if both are private networks directly connected, we can use a router to make communication between networks. That's one thing. Okay. So both are public networks, different networks, both are public networks. You want to make them communicate each other. Okay, different networks, but public networks, public IP addresses. We need a router to make them communicate. Simple routing tables are required. But now it is internal, it is a private IP, but outside it is public network. Private to public direct communication is not there. Directly routing is not there. Private IP address cannot route into public. So you're asking google.com, your google.com don't know your IP address. They don't know your IP address. You're using private IP, they don't know your private IP. They can't reach you with your private IP. But you're asking google.com from your system, right? How it is happened? There is a technique called NAT and PAT technique. NAT and PAT technique. Network address translation. What is NAT and PAT? Network address translation techniques. Network address translation. In this one, what happened? In this one, what happened? We'll see. We have a private IP. For example, I take 172.16.0.1. This is my 11. So this is my one PC, APC IP address. APC IP address, a private IP. In this router, or sometimes ISP will do it. So in our routers, what we do it? What is the private IP? So when this system APC IP address, it is a APC IP address, for example. When it is connecting to the public, when it is sending data, when it is sending request to the public, when it is trying to access public kind of stuff, it has to send with the public IP. So we have to buy public IP address and map this public IP address into in our router. So first, when you are sending a request, so it's private IP. Your APC has a private IP, but APC send a request in a router. It is changed. It mapped to the public IP. So it will router will send with the public IP to outside. So in a public, no one knows what is your system IP. It will send through your public IP only. So finally, you reach the destination. Destination returns means destination also reply to your public IP only. So you got to reply to your router, router to your system. So like that, how many systems need to be connected to the public? For all these system, I map their IP address into the NAT translations. For example, I have a 10 private IP addresses are there. Then I have to buy at least 10 public IP addresses. Okay. I have a 10 systems need to be connected. So then I have to buy 10 public IP addresses and I have to map into the router NAT translations. Once again, A want to access something google.com. So A will send request to the router because it is outside of network. It send request to the router. So router check what is the IP. Internal IP is 170.16.0.11. It mapped to the network is 200.2.3.11. It will send a request outside with this 200.2.3.11. It reaches the destination. Destination take your request and it will give you a reply. It reaches up to your router and router again it is retranslated to the back to the your IP address, your private IP, and it will send to your system. So someone knows your private IP, if they can't reach you. If they know your public IP, they can able to reach you. One more is there, guys. For example, in your organization, you have some server. For example, you have a web server. So you are running a website. You're running a website. From inside, from DPC, you are accessing this web server. So you have to use web server IP address, right? Simple. Using web server IP, it's a private IP. Simple, you can able to access, no problem. But someone in the internet want to access your web server. Which IP they will do it? Which IP they will access? With your IP or private IP, they can't access you. So what they will do it? Again, inside they will map. This is web server IP address. This is IP address, private IP, and this is the public IP. So whenever someone requests, they will request with the public IP only. Again, just public IP translate and to the private, and our server receive the request. And our server sending a reply when it is replying with the private IP only. But again, it will send through the public IP and receive by destination. Okay. So internally, it stays private only. Internal communications are all your intranet, internal private network communicate with the private IP network. But when it is communicating outside of your network, okay, it's sent with the public IP. Even you have a servers, public access kind of stuff. Even Google.com, Facebook.com, you're accessing, but internally, maybe there is use some different private IPs. But whenever we are accessing with their public IP addresses only. Same way, you are having a server, some storage kind of stuff. If you want to make others to access your server, so internally it's private, but when it is accessing from public, it's a public IP address we use it. This is NAT, network address translation. Okay. One more is there, that is called a PAT. In a NAT, what I said, guys, in a NAT, what I said, it's one-to-one type. One private, one public. You have a 10 system need to connect it, means 10 private IP address need to be connected to network internet-wise public connectivity. You need a 10 public IP address, like one-to-one type. But in your home, how many systems are there? You have a smart TV, a laptop, a desktop, a mobile phone, a tablet, like multiple mobile phones are there. So think like you have 5, 6 devices. So you need a 5, 6 public IP addresses are required. So those many public IP address provided by your ISP or yourself, it is very cost oriented. So we're changing that pattern. It is using port map technique. What is this port map technique? It is same private IP. Different systems, their private IP addresses. We are not mapping, any static mapping, we are not doing. It's a kind of dynamic mapping, means a random map technique. Okay, in a NAT also there is static NAT and dynamic NAT, but this is PAT. The PAT means port address translation. PAT means port address translation. This PAT also called as NAT overload. NAT overload. Why it is NAT overload? Because you have a 10 systems. 10 system need to connect public. Means you have to access resources available in the public, like google.com, facebook.com, youtube.com, you want to access. You have 10 systems. So 10 public IP address you have to purchase if you are using NAT. But if you are using PAT, simple. One public IP is enough for all 10 systems. But how it is possible? Using port map technique. There is no specific port map number is there. Okay, you can use any port map. Okay, so just for our example, I am writing this one. So for source, like our internal, we are assigned a port map port and the destination also like a for public port. So different private IP addresses use single public IP address with the help of port map technique. So for example, I open my browser, I open google.com. So it will send a request Okay, so it will send a request. And with a public IP request, it will sending, right? So when it is sending, automatically in the router, it will create. So who is from address? For example, 170.16.0.12 is a from address. So what is the destination? What kind of protocol? So based on that, it will generate a port number. It maps the port number of my local system, IP address, private IP, and as well as public IP also. It maps the port number. It send the request. By that, both will understand, yes, what port it is connected. Okay. It's not guarantees that same kind of stuff, but it's a random port numbers generate. So there is no static port number. So when you send a request, then only a port number is assigned for your both system, and it is stored inside your router only. So nowadays, what your network you are using, this one. Someone knows your private, already I told they can't reach you. Someone knows your public IP, also they can't reach you. Why? Because of port mapping. Because they reach with your public IP, but your is not a public one, right? Even router cannot translate. Why? Because they reach with your public IP, but which port your system is mapped? No one knows because it's a random port. Now you are sending request, a port is assigned. For every request, new port is assigned. Same system, multiple requests. So multiple ports are assigned. So I open google.com, one port. If youtube.com, one port. So I close both the things. Again, I open any another youtube.com. Again, it will generate another port number. So random port numbers are generated, binded. This will maintain till the session is completed. Once session is completed, these ports also will be damaged, not gone automatically. So someone reach with your public also from your router to which device? You have already 10 devices using same public, which device? So when port also not constant, port also changes. So you're automatically in a secure network, guys. If you are in your home, your Wi-Fi router, so you're already in a secure network because no one can reach you with your MAC address, private IP address, and public IP address also. Okay, that's the point. That is PAT. PAT means NAT overload. We are overloading all private IP addresses into public IP address. We are overloading all the private IP addresses into single public IP, one public IP, and here it is 10 private IP, one public IP. Here it is 10 private IP, 10 public IP in NAT, but here it is 10 private, one public type. Okay, so whenever you send a request, so router assign one dynamic port number for your private and as well as a public. It maps, it stores that information and send outside a public request. So once you got a reply, again, it is retranslated. But in this PAT, guys, in the PAT, you can't get connected from outside. In NAT, you can get connected from outside. Like you have a server, a private IP address with a public IP, you can connect it. Because when router understands this is the public IP request and this is destination system, it will understand. 200.2.3.11 means it is 170.16.0.11. It will understand if you use NAT. You got a request with a 200.2.3.11. You received that request. It's sent to the 170.16.0.11. But PAT is not like that. You can send and that you will get reply. But no one can able to reach you. Why? Because you put a server with an IP, for example, same example, instead of NAT, you use PAT. Someone reaches your network with a 200.2.110. You don't understand to which device we have to forward. So why? Because all devices are using the same public IP. Which device it is, which map it is. Okay. Any static port maps are there, then maybe we can use it. But dynamically mappings, we can't get access to from outside. That's why I said even someone knows your public IP, they can't reach you. If they want to reach you, you have to reach them first. Then they will reach you. You send google.com a request, you get reply from google.com. but directly google.com won't come to you. How google.com contact you? Use a Google Chrome browser, Gmail account. So then already you are sending requests. So they are reaching to your system. That's the way. Okay. If you don't access, they won't come to you. Okay, and that is a NAT and PAT technique, guys. This topic I want to complete. This part, if I complete it, so tomorrow we got a time to discuss YSA model, okay, and protocols, port number, TCP, UDP, all are important, guys. Everything, TCP, UDP differences, protocol, port numbers, okay, and one more is there in this one. Okay, each protocol, what is their PDUs, okay, these are all very important. Source and destination, OSA model-wise communication, TCP IP protocol suite. Okay. OSA models, what are the different? OSA troubleshooting using OSA model, different networking commands, ping. Okay, using how to test the communication between ping command. Okay, that is also we'll discuss. And one topic is that is. So I'm going to stop here, guys. And already I told people should be there till the last of the class. Till I said completed, you should be there, but some people are left. So that irritates me that. So I'm going to take screenshot of your attendance. We'll see. We'll check with your answer.